wanted to study the ARM controller. So if I wanted to study the ARM controller, what is the concept we already know? A microcontroller may be having any architecture. What is that? Either it may have von Neumann architecture or it may have Harvard architecture. Harvard architecture. Okay, it may have this architecture or that architecture. Okay, so if I have one Neumann architecture or Harvard architecture, or a microcontroller may be having RISC or CISC architecture, or RISC or CISC architecture, CISC architecture. Okay, so a microcontroller may be having CISC or RISC architecture. So usually what we say, a microcontroller, you can say MCL, right? A microcontroller has, what is the common architecture? It has a RISC architecture followed with von Neumann, you can say von Neumann architecture generally. Or sometimes it is not mandatory to have von Neumann. It may have Harvard architecture also, or CISC architecture, okay, or in combination. But generally microcontroller is of RISC type and von Neumann type. Now for this, can you tell me what is RISC and von Neumann architecture means? Quickly. Come on. Okay. Am I audible, Ayush?
Yes, sir.
I am audible, right? Okay.
Yes.
Please listen and read out continuously with me. If you read regularly with me, then it becomes very easier for you to write any point of time, any question whenever it is asked. Please understand. Now we are talking about ARM. ARM is a 32-bit RISC microcontroller. So when I say this, we should know clearly what is RISC means. So RISC and CISC differences we know, von Neumann and Harvard architecture differences we know the difference between microcontroller and microprocessor, all the stuffs we already know. Okay, you need to recall. So special thing about RISC, what is RISC architecture? A RISC design architecture, if somebody asks, you should be able to explain its characteristic features. What is that it has? It has the property or the rule called as instructions, special concept called as instructions. It has the very interesting concept called as pipelining concept. It has the interesting concept called as registers. It has completely involved with registers. And I'll say the last one, it has the load and store architecture. So load and store architecture. You need to explain in detail about these 4 points. Instructions. So RISC has simple set of instructions. That is the first statement. Simple set of instructions. All instructions are fixed. All instruction lengths are fixed. It means fixed length instructions. Since they are fixed length instructions, every instruction can be executed in a single cycle. That's the most important point. RISC architecture always follows the instructions which are simple in nature. Every instruction is fixed in length and they can be executed in a single cycle. I told what you mean by a cycle. Single cycle. Now once the instruction is executed in a single cycle, it means that any kind of frequency can be offered. That is the clock frequency. So they can operate at very high frequency in megahertz. Okay, in megahertz the instructions can be fetched, decoded and executed. So such instructions are available. So instruction is the most important rule to have the RISC design architecture. Then pipelines. Since if I have a complex operations to do, I have simple instructions. Pipelining is a technique adopted in RISC, in which the big task is divided into smaller tasks using the simpler instructions available and executing those tasks simultaneously. Executing those tasks simultaneously leads to the execution of the complex instruction or the complex operation in no time. That is what the meaning of pipelines. Pipeline means execution happens simultaneously. How execution happens simultaneously? If I say one instruction is at fetch state, another instruction might be at decode state, another instruction might be at execution state. It means when I go to the decode state, next instruction will be at fetch state. So there are three states: fetch, decode, execute. So as the instructions are fetched, they are moving: fetched, decoding, and executing. When they come to decode state, the next instruction will be in fetch states. That's what uh, uh, thinking thinking before the instruction gets decoded, that is called as pipelining. Pipelining means simultaneously fetching the instructions for the execution. So there are various pipelining modes or the stages depending on the ARM processor. If ARM is a RISC processor, ARM 7 has 4 stage, ARM 9 has 6 stage pipelining concept. Pipelining means fetching the instructions parallelly and executing. Okay, executing parallelly, you can say. So pipelining makes the execution of the program faster. That's the most important aspect of it. Registers, the most hard or the building block of the RISC architecture is the set of registers it has. The registers may be a general purpose registers or special function registers. Why he is talking more stress, or why he is giving more stress on registers? Because registers play an important role in executing any sort of instructions in the RISC processors. That's what RISC design always have the rule called as registers, usage of registers. These registers are helpful to execute any sort of instructions. What is the meaning? There is no need of memory associated with the instructions. It means in CISC architecture, we have the instructions associated with the memory also. In RISC architecture, we have the instructions associated more on registers rather than memory. Only two registers which are associated with memory are load and store instructions. Load and store instructions are the only two instructions in RISC architecture associated with the memory. Remaining all instructions are associated with registers only. How? When we look into the instructions, how they are associated with registers, you will come to know. That's what registers play an important role in RISC architectures. There are 16 general purpose registers and two special purpose registers or program purpose registers, you can say program status registers. So 16 general purpose registers, 2 program status registers, total 18 registers are available to do any sort of programming in RISC. So registers plays an important role. Registers can handle data, they can store the data, they can store the address also. Okay, they can store the data, they can store the address also. Okay, you can treat registers as temporary memories over here in the RISC architecture. So registers are most useful. Then the last rule supported by the RISC architecture is load and store architecture. It also has two special instructions called as load and store, which which are specifically used for storing the data onto the memory and fetching the data from the memory to the registers. Everything or the programming totally happens with the registers in the RISC architecture, but load and store architecture means load and store instructions which are associated with RISC architecture helps to load the data from the memory to the registers, store the data from the register to memory. Only two special instructions which are supported by RISC. These four things forms the entire RISC architecture wherever you use. Any microcontroller, 8-bit microcontroller, 16-bit microcontroller, 32-bit microcontroller if you take, or any ARM processor if you mention, if they are following RISC architecture, definitely they are following these four rules. It means most of the programming is done with the simple instructions. Pipelining concept is used. Registers are rigorously used to write the program, and load and store instructions are used to fetch the data from the memory and write data to the memory. That's it. Now when I say ARM processor design, if I say what is the ARM design architecture, if somebody asks, simply you should say that it is the RISC architecture only with special features. RISC architecture with special features. This is what I discussed in the last class. Special features. RISC architecture with special features. Can you see this? Special features. Okay. RISC architecture with special features. Now, what are those special features if somebody asks? Then you just have to say, what is that it has? Can you tell me? What is the RISC design philosophy includes? What is the RISC design philosophy includes? Quickly. Can anyone tell me RISC design philosophy? What is the RISC design philosophy includes? Pramod?
Sir, high code density.
Okay, very good, very good. That's the most important. If I say what is the concentration, high code density, then what else?
Low
Low
cost.
power consumption,
Yes,
low
sir.
power consumption, very good, low power consumption, low cost, you can say. Then what else? Low power consumption means it is associated with what? It is associated with battery with small size battery, you can say. Low cost, what else? And what else? ARM feature, ARM design architecture needs to have high code density, low power consumption, low cost, and small coverage area. Small coverage area. It means it is fabricated with a small silicon die. Any RISC architecture, whichever is there, it is small only. But ARM especially, ARM is a RISC architecture which covers a small area in the single chip. Small area on single chip, you can call it as single chip. Remaining area is for external peripherals. Remaining area is for external peripherals. Okay, peripherals. So remaining area is for external peripherals. Next, what else? What else it has? The most important points. If ARM is a RISC architecture, it offers high code density, low power consumption, and also it runs one more interesting point. What is that? Special debugging technology it runs. Debugging technology it runs. Technology, debugging technology it runs. Debugging technology, special debugging technology to know how program is getting executed, to know how program getting executed. This is the speciality or a special design feature of ARM processor. How ARM design architecture? It is a RISC architecture along with this feature. Most important, which we should not forget. What is that? First one. What is the other things the ARM design feature has? Other things than the RISC architecture, ARM has variable variable cycle variable cycle execution for certain instructions. variable execution Variable cycle execution for certain instructions. What is the meaning? It means I said that RISC architecture is having the instructions which are fixed in length. Fixed in length means single cycle is sufficient, but here variable cycle is also allowed in ARM. Why? Because certain instructions are need more number of cycles. That property is supported. That is an extra feature. What is an extra feature? Other extra feature is inline barrel shifter. Inline barrel shifter. A barrel shifter is an extra thing used. It is a shift register. So before giving it to ALU, it is given to barrel shifter, so that barrel shifter and ALU What is that? And ALU. Barrel shifter and ALU together, inline barrel shifter is there along with ALU and ALU together. What they do? Together will address complex will address complex expressions. Means complex expressions can be easily solved if I have barrel shifter and ALU are together working. That barrel shifter extra feature the ARM architecture has. It has extra block called as barrel shifter. So it also has, what is the interesting point, TDMI? What is that? It has thumb 16-bit instruction set. You should not forget thumb 16-bit instruction set. Please remember, all RISC architecture does not have thumb 16-bit instruction. That's what ARM design architecture, how it bit differs from RISC design architecture. RISC design commonly has instructions, pipelines, registers, and load and store are the common property with any of the microcontroller, because all microcontrollers might be RISC architecture. ARM is also RISC architecture. It has instructions, pipelines, registers, and load and store architecture. Along with this, ARM also has variable cycle execution property. ARM also has inline barrel shifter to solve the complex expressions along with ALU. ARM also has thumb 16-bit instructions. For what purpose? For what purpose? To address different memory locations. Please remember this: different memory, different sized, you can say, different sized memory locations, different sized memory locations. Okay, different size memory locations. That's it. Different size memory locations. Then what is the next most important extra design property of ARM compared to the RISC architecture? Design architecture of ARM has extra, what is that? Conditional execution. Conditional execution. You please remember conditional execution. Don't forget conditional execution. It means I can execute the instruction before a condition is satisfied. If condition is not satisfied, I don't have to execute the instruction. Conditions are checked initially. Then what else I have? I have extra feature called as enhanced instruction. What is the fifth one? Enhanced instruction. What do you mean by this? Enhanced instruction set. It means it supports, for example, 16 cross 16 multiplier. I said like this: 16 cross 16 multiplication. 16 cross 16 multiplication can be done. 16 cross 16 multiplication can be done easily with what? DSP instruction set. So it means it adds extra instructions called as DSP instruction set. It supports. So ARM is like this. That's it. So did you understand, Pramod?
Sir, what is meant by barrel shifter, sir? What it do?
Yes. Now I'll come to that. I will come to that when I'm explaining the ARM core. Just listen, give me a few minutes. I'll come to that. Now, this is what we discussed. All microcontrollers, what they have? RISC design philosophy. What RISC design philosophy has? These 4 points: instructions, pipelines, registers, and load and store architecture to work. That's it. To work means what? If the processor is working means the processor has to have instructions, the processor has to have pipelining, processor have to have registers along with it, the processor has to have load and store instruction in RISC design. If it is called as RISC design, these properties it should have, these rules it should have. If I say ARM is a microcontroller, if it has RISC design architecture, along with it, it has its own design, then I'll call it as ARM design philosophy. ARM design philosophy has all RISC properties along with extra properties called as it can generate high code density, it can have low power consumption technology, it can have low cost technology, it can occupy small coverage area. It depends on how the fabrication is done. It can have debugging technology. It also has variable cycle execution for certain instructions. It has inline barrel shifter which helps ALU to address complex expressions or to solve the complex expression. Barrel shifter helps. Barrel shifter is just simple shifting operation which will takes place. When you see some examples while doing the instruction set, automatically you will understand. It has extra instructions called as 16-bit thumb instruction set to address different size memory location, as well as to make the processor speed faster. It also has the conditional execution feature. What is the meaning of that? Every instruction is condition is checked before its execution. It also has enhanced instruction set which supports the specific operations like 16 cross 16 multiplication. It means enhanced instruction set means the ARM processor supports DSP instruction set externally. That feature, extra feature it can have. This is the ARM design philosophy. So with this philosophy, I can have an embedded system. An embedded system contains ARM microcontroller along with some other controllers along with peripherals. In the last class, I have shown that block diagram. If I say an embedded system, what is an embedded system? If a mobile device is called as an embedded system. What mobile device has? Mobile device has ARM processor. ARM processor is nothing but ARM design philosophy it has. ARM architecture it has. What do you mean by ARM architecture it has? It has it has all the RISC properties along with the extra properties what I have mentioned. If the ARM architecture is there, along with that we have extra peripherals which are connected to it, forms the complete embedded system. Now what that simple embedded system means? An embedded system is a system which does a particular task. In the last class I have shown with the functional block diagram in which ARM processor was there and some 3 controllers are there and some 4 peripherals are there. If you recall or if you see to it back, what all things I have mentioned, ARM processors are there and there are controllers called as memory controller, interrupt controllers are there, and I also mentioned that peripherals like counter bar timers are there, Ethernet block is there, okay. So some other blocks totally forms an embedded system. How these blocks are connected to form an embedded system? All these blocks are connected by data buses. Data buses. That's the major importance. Why I'm saying only data buses? Because data buses will carry the data from one component to other component, or data can interact with all the blocks when they are connected by data buses. Bus is the one which carries the information that you know. So that total representation is called as embedded hardware. So embedded hardware, what it has? Embedded hardware has, in this case, I am talking about ARM. That's what I'll say. Embedded hardware has ARM processor along with some controllers called as memory controller and interrupt controller. Those will connect some external devices to the ARM processor. That's what those controllers are required. As the name itself indicates, memory controller connects the external memories to the processor, and interrupt controller means connects the external interrupts to the processor, that is interrupt controller. So memory controller, interrupt controllers are the associated controllers with the ARM processor. Along with that, we have peripherals called as timers, okay, and I said counters, Ethernet block, what are all the other stuffs we have mentioned. ADC, DAC, all these things are peripherals which connects the external world to the device. Which device? ARM device. Sometimes ARM processor is also called as ARM core. Core is nothing but processor. Wherever you will find the word core, CORE core, it is nothing but processor. Meaning is processor. ARM core, when I say ARM processor, that's the meaning. Embedded software means what? Any software which gives the life to the embedded hardware is a software. So what are the lining of software? Software is nothing but a program. When the program is written onto the memory, then only the processor starts working. How the processor works, how the microprocessor works, how microcontroller works, how processor works in general. If somebody asks, how do you say? The program first must be loaded into the memory. Which memory? Either it may be a permanent memory or a temporary memory. Temporary memory means RAM. Permanent memory means ROM. We will call usually the system which we design, which is called as hardware. The hardware definitely has permanent memory called as main memory, ROM, read-only memory. Permanent memory means it is not erasable, we usually say. RAM means it is erasable. It can be rewritten. The memory which can be rewritten. Something we write means it can be rewritten. So ROM and RAM are the two memories which are available. So now what happens? The program whatever we write is called as software. That should be placed onto the memory. Now the process starts. How the process starts? Just simply explain that. How the process starts? Once I put the software here, let's say, so once I put the software, what is the idea behind it? Once I put the software, the hardware has to work accordingly. So if I draw the blocks like this, okay, if I draw the blocks like this, okay, if I draw the blocks like this, now let's understand what is that. This is the memory. I'll call it as memory. So, okay, and this one I will call it as what I can call it as. Let's say register. Let's say register. Just for example, just for simple example, very simple example. So it means that, does it sufficient to write like this if I call, just to understand, 1 second, why it is not allowing me to write. Okay, it's register, let's say, and if I take one more block, okay, if I take one more block, I'll just name it as, simply just for an example, I'll just name it as, 1 second. So if I take now in this, if I write the name as like this, so are you able to observe promo 3 blocks?
Yes, sir.
Oh,
Register memory.
yeah, some roughly I have written some 3 blocks. I'll call these 3 blocks as functional block. Now you understand. Let's say all these things are there in one particular closed loop. Let's assume inside a counter they are there. So what I will do, I will put the program here. That's it. So what is the simple idea? I'll prove how the processor works. I'll put the program over here. Program means what? If somebody asks, program I'll put over here. What is the program? It is the collection of instructions. Collection of instructions you can call it as. Collection of instructions written sequentially. You can say written sequentially. You can say sequentially. So collection of instruction is a program. It means that this is a memory. So this is the memory. So when I write the memory, so how the memory is there? It looks like this. I'm unable to draw the straight line. Please bear with me. Presume these are straight lines. Okay. Now the whole memory is divided into locations like this. I'll put one data in this. I'll put one data in this. I'll put one data in this location. I'll put one data in this location. The rows, different rows. If one row, I can name it as one row. If I name it as taking 8 bit, 8 bits it stores in one row. So then I'll call it as 8-bit memory. If it stores 16-bit, then I'll call it as 16-bit memory. If it stores 32-bit, I'll call it as 32-bit memory. Okay, 32-bit memory. So like this, I have the memory. Instructions are 8-bit instructions, 16-bit instructions, 32-bit instructions. If I'm talking about 32-bit RISC architecture, I mean the ARM processor, then it is a 32-bit instruction. If it is a 32-bit instruction, if I'm using the memory 32-bit memory, no problem. 32-bit memory means what? One row represents 32 bits. It can handle 32 bits. So I will take data from this. I will take data from this. From where to where I'll take? I'll take from first location to registers, and from registers I'll move to ALU. I'll perform the operation. I'll move to the register. If I want to store the data, I will store the data in some other memory location. That's it. Very simple operation. You try to understand. I'll take it from the memory, put it in register. From the register, I'll put it in ALU. ALU performs the operation. Let's assume. Simple example, addition operation. If addition operation is done, the result is put back in some other register. You call this as register bank or register file. So many registers are there in register block, you can say. So one register I'll put it I'll put it over here in one register. From that register I'll take it to ALU. ALU performs the operation and puts the result back to another register. From another register it is moved to another memory location. This is the simple operation, as simple as that. But it is actually the complex process. What is that complexity is there? I need to explain these lines, what I have connected lines. Okay, what are the lines what I have connected? These lines are called as what? These lines, I'll call them as buses. Now buses means the one which carries the data. The buses means one which carries the data. Buses carries the data, right? Carries the data. 8-bit data, 16-bit data, 32-bit data. If it carries 8-bit data, it is called as 8-bit bus. Bus of size 8-bit, 16-bit bus, 32-bit bus, 64-bit bus. So buses may be like that. But buses are of three types. What is that we said? Data bus, one which carries data, address bus, one which carries address only, and control bus, one which carries control signal only. So control signal and control bus and address bus are usually hidden in the diagram, which is not shown because they do their job automatically. It means I didn't draw the unit which is called as control unit. So there is a control unit which takes care of there is a control unit which takes care of the operation. The control unit which takes care of the operation. What the control unit will do? Control unit will put the control signal on the control bus. Then the address is put on the address bus. That address bus will point to the particular address of the memory. From that memory location, because address of the memory location, from that memory location the data is fetched. The data is fetched onto the register by the processor. So this is the complete diagram buses, which are called as data buses, data bus, address bus, and control bus. Control bus. Please remember, control bus. But what usually we worry? We don't worry for control bus and address bus. Address bus little bit we worry, but control bus we need not worry because automatically things will happen. We presume all the things are connected. So unless control signal is passed on to the control bus, address bus won't carry the address and point to the memory. From the memory, that value will be fetched to the register through data bus. So data bus carries the data to the register. From register to other components like ALU, multiplier, barrel shifter, all different functional blocks can be connected with data bus only. So that's what we worry for data bus and address bus more. We are interested in data bus and address bus more. Even sometimes we forget sometimes address bus because we rarely connect, or less number of times we connect to the memory to fetch the data. Automatically things will happen with the address bus. That's what address bus also sometimes we forget. So the most important is data bus, which makes the data to flow across all the blocks. That is the idea behind. Now let us understand quickly, to start with, how the ARM processor works with its block diagram. With this idea, we'll move on now. So what is the idea I was talking about? Now the program is stored onto the memory, which is called as embedded software. What are the different embedded softwares might be available? It might be the first code called as initialization code. Second code can be called as operating system. Third code can be called as memory related code. We are not going to wreck our head in understanding embedded software. We are only interested in understanding a simple program to perform different tasks. Different programs to understand different tasks how it can be performed in ARM microcontroller, not to knowing about how operating system works, how initialization code works or boot code works. No, all are all are ready-made codes which are already loaded onto the memory, which memory called as main memory. From the main memory, for example, in your hard disk, it is a C drive where you are installing the operating system, where you are installing your boot code, everything. So it's a main memory. Now, whatever the application program you will write, that program usually be associated with RAM, read-only memory. So any memory can be shown like this, as I have shown in the diagram, and the data is fetched to the register. It can be connected to the many other blocks, and the operation continues. How the operation happens? The operation always happens with the simple procedure called as fetch, decode, execute. Now let's understand this. What is this? I'll just go immediately to that. So what is the idea I was talking about? You will come to know now. Quickly we'll do that. So uh, if you just see the diagram, is my diagram is visible?
Yes, sir.
Yeah. What is this diagram? This is called as the ARM core. Now we will start understanding the ARM core. We'll explore the complete ARM core. ARM core is nothing but ARM processor. Now we'll understand how the ARM processor works. We understood how microprocessor works. We understood all different microcontroller works, something like that. Now we clearly understand, because I need to write in exam. If somebody asks me, can you tell me how ARM processor works, how ARM processor functions, how ARM core works, how ARM core can be realized, then you just have to draw this block diagram, explain in detail. Now you understand how this block diagram is drawn. The ARM processor or ARM core is nothing but the collection of different functional blocks connected by data buses. Here you observe there are different functional blocks. You have to remember what are the functional blocks. The ARM processor has, it has instruction decoder, it has sign extend block, it has register file. Register file means collection of registers. You understand now, architecture has registers here. It has extra component called as barrel shifter. It has a functional block called as ALU. You know, all microprocessor, microcontrollers, everyone will have ALU. So ALU is a mandatory one. And it has an extra block called as MAC. This is called as multiplier and accumulate block, multiplier and accumulate block. Another interesting block is here, address register block. Another interesting block is incrementer block. These blocks together forms the ARM core. So if somebody asks, draw the block diagram of ARM core and explain the functionality of ARM core, or explain the function of each block in detail, so that the ARM processor working functionality can be realized. Now very simple. Let me explain the operation. Easy way. You try to understand now. As I said, the interesting point of ARM architecture or ARM design philosophy, what is that? It has most associated with RISC architecture. What RISC architecture has? RISC architecture has important concept called as instructions. All instructions will come. All instructions will come to the instruction decoder. That is first point. Important property it has is registers. RISC architecture has important property called as, or rule called as, registers. It has registers here. Another important property is called as pipelining. It executes the things in pipelining. And another important property is called as load and store instruction, which is happening with the help of address register and incrementer. Let's understand the function first, then everything becomes easy. Very simple. This is the processor. Now this processor has to be connected with the memory. Memory is not shown here. So the data from the memory is taken. How the data from the memory is taken? So when the processor starts working, how the data will be fetched from the memory? In the fetch cycle, The data will be fetched from the memory when a particular program counter PC, it is shown in the diagram. Can you see this PC above which R15 is written? R15 is a register in the register file. R15 is a register in the register file. How many registers are there in the register file? You observe R0 to R15, total 16 registers are there. R15 is shown outside. This register can act like a PC. It means that program counter. So first of all, processor looks into the register called as PC, program counter. Which is that PC? PC is nothing but R15. R15 is one of the register in this register file. All these registers are 32-bit registers. It means they can handle 32-bit data. R0 will handle 32-bit data. R1 will handle 32-bit data. Likewise, R15 will handle 32-bit data. Total 16 register. R15 not only handling the data, it also acts like PC. That's what, please remember, registers plays important role in the processor. How many registers are there? 16 registers are there. Two inside registers which are not shown, which are called as program status registers. Two program status registers are there, they are inside. Total 18 registers are there. So register files are 18 in number, total 18 registers. Out of which, please remember, R0 to R12, R0 to R12 are called as general purpose registers. They can be used for any purpose. It means for all instructions will make use of these registers. R0 to R12, R13, R14, R15 are for some purpose. In that, R15 is a program counter. Now let us start. What do you mean by program counter? Program counter is a register which points to the memory location where the programs or the instruction is stored. Now let's assume this program counter is having the address. R15 is a register which is a program counter. This register has the address. What is the address? 32-bit address. That address is nothing but address of the memory. From that memory, the data is fetched. Please understand, the data is fetched. Now understand, all these functional blocks are connected to each other with the data buses. These lines called as data buses, and the direction is called as the flow of data. Now you understand, data is coming in. One more is showing data is going out. When I show go out, it means that data is going to memory. Data is coming from memory. So you can observe the direction. Data is coming from the memory and it goes to sign extend block. Sign extend block will convert the 32-bit data, which is signed form or unsigned form. We will see how to write a signed integer and unsigned integer and how the conversion. So sign extend will convert 8-bit data into 32-bit data, or 16-bit signed number to 32-bit unsigned number. So conversion happens here. What is the conversion? I need to get into 32-bit data. If the data is 8-bit data, 16-bit data, 32-bit data, it is converted into 32-bit data. It is the first thing sign extend will do. Or it also converts unsigned into signed int or signed integer into unsigned int. That sign extension block will do that. The value coming out is a 32-bit data. Now you please see, I am saying it as data. Data may be an instruction. The data may be an instruction. For example, add, I'll say add is the instruction. Add 10 comma 20. Let's say no such instruction is available. I'm just giving an example. Add 10 comma 20. 20 is added to 10. The result is 30. You will say add. Who will understand it as add? Add is an instruction. Instruction, when it comes, it goes to the instruction decoder. So as the data is an instruction, please understand, add is an instruction. It goes to instruction decoder. Instruction decoder decodes. So fetch is done, decoding is done here. Once decoding is done, the machine data, now it is converted. What is that? Add, add goes to instruction decoder. Decoder converts into hexadecimal number. It means into machine code. So opcode is converted into machine code and the data goes in. The data goes in. If it is an instruction, it directly goes. It need not to check for sign extend. If it is a data itself, data means, for example, 10 I am passing. 10 does not go to the instruction decoder. 10 is the data, directly comes to the sign extend. It checks for the sign or converts the sign into unsigned into signed int according to the requirement, and the data is 32-bit. That 32-bit data is sent to the register. If it is an instruction, that instruction is sent to the register. Please understand. Instruction is decoded into machine code, and that machine code is also 32-bit, and data which is also 32-bit. Anything it may be, either instruction or data. If instruction, it is decoded and sent to the register. If it is data, directly sent to the register. So totally it comes to the register. The registers are R0 to R15. They store the value. What is that value? Instruction. It stores the instruction in hexadecimal form. It means machine code form. And also the data. Data also is stored in the register. So instruction, if it comes, it is converted from instruction decoder and it is stored in the register. If data comes, it comes directly through the sign extend and stored in the register. Everything is stored in the register. Now register plays an important role. What it does? Now the instruction, based on the instruction. For example, if I write an instruction, add R1 comma R2 comma R3. If an instruction is written like this is an instruction for ARM32 RISC processor. So instructions should be particularly of ARM instructions only. I cannot bring 8051 instructions for ARM instructions or microprocessor instructions to the ARM instructions. So if we brought one instruction which is called as ARM instruction, now that ARM instruction is a 32-bit instruction, add R1 comma R2 comma R3, where R1 R2 represents source registers and R3 represents destination register. That's what the general name they give as R and RM. Okay, so we'll stop here. The next class sir is waiting. Okay, so we will continue the architecture in the next class with the simple register explanation, how they perform by taking certain examples.
Sir. Sir.
Yes, Pramod?
Sir, the videos in YouTube were not playing, so it's showing private video.
Now,
Yes,
no,
sir.
you need to play with the links what I have sent.
Yes, sir.
I mean, oh, they are
It's
not
showing
playing.
private video, sir.
Oh, they are
Yes,
showing
sir.
private. Then I'll again cross check. I'll just ensure that it will play. Huh? Okay.
Okay, sir.
I'll call you again then after doing that. Okay.
Okay, sir.
Okay, fine.